Dear friends, coming to you after a time. Hope you're all fine. We are shocked with the news around, but kindly take care and stay safe. Alright, the last video lecture, if you remember, please go back. That was how to create and represent a sparse matrix using linked list concept. And we saw what is a sparse matrix and how they are represented. Now we are going to see the addition of two sparse matrix. Here is a basic algorithm which you can always translate straight into a program. So here's a structure required to represent a sparse matrix. Of course, I've called it node. All right. Uh, there's a row. There's a column value. The row value of a particular item we have seen. Its column and the value there. And pointing to the next. So let's imagine we have two matrices, sparse matrices. Let A and B, the two matrices A and B. Imagine being matrix by dimension they will be, let's say, an n into n matrix. Alright, now let us see how the reading takes place, the values. Okay, so we saw in a sparse matrix we saw that some values could be positive, all other values are positive or negative. Of course, all other values are zeros. So let's imagine we have a matrix of that type, a sparse matrix. When we read, of course, we will use the nm looping, two loops, so that we can read in the position. Now we are going to represent it as a linked list, so never use an array, because that is not the purpose of this. It will be wasting storage. So never use an array matrix, but read as single integers. So look at this algorithm. Of course, this p is used for first case, which we have already seen. So I'm going to read a value, let's say for I row jth column proceeds n into m times, and for each time I read a value xu. If it is not 0, only then do I need it to store in my linked list. So if it is not 0, I'm going to store that value. Okay, so if read x, so read all the values. For example, a 3 into 3 matrix, 9 items, read it as x. Whichever is non-zero, I will store it. So the moment I find a non-zero value, that I row, that column j, and that value x is passed to my existing list. I'm using my insert last program that we have already seen. So I'm going to insert it to the end of the existing list. If it is a first, fine. If it is successive, it will insert to the end of that existing list. I think that should be clear. Explanations here. Alright, so here I have created, let us say, the matrix required for storing the two matrices. So I will do it time for A and B. So if we want to look at the insertion, this is how it takes place. Alright, first time and the remaining. So here is an explanation. The insert function, it reads I, reads j and value and existing list. So either I proceed to the last end of the list, that is when successive, or to the first. So, and the value I is stored to its row, j is stored to its column, the value that is coming, v is stored to value, and proceeds to end. So this will take care of all the insertions. Should be clear. We have seen insert last function. Now let us see about adding. Okay, so this is my add function. I'm returning it as a pure algorithm. Okay, so this is to take care of my first case, p equal to null, another function. So I'm going to add two matrices A and B, which are represented by linked list. So while both not equal to null, just like we have seen how merging of linked list takes place, while both the same condition, while A not equal to null, B not equal to null. Now when will there be an addition between the two matrices? It will happen only when A's row matches B's row and A's column matches B's column. So A's row equal to B's row, and if columns are equal, that means in both matrices in the respective same positions there are values. So then we will add a value plus b value. But when do I need to store it? I need to store it only if the result is not 0. It's possible we have at a position in A and at the same position in B two values that are complements. Suppose minus 2 plus 2. So they would add and add up to 0. You don't have to store that. So if it is not 0, I'm going to pass that value and get inserted into my resultant list. So for example, in this case, A's row, A's column, both are same here. Then the values are added, A plus value, B's value, and passed to P. P is my existing list, that is my same insert function. Okay. Then A is advanced, B is advanced. Suppose rows are same, columns are less, then A's row, A's column, A's value, and pass to the list, A is advanced. Otherwise, A's row, B's column, the rows are the same, B's rows would be fine, B's column, B's value, and B, and B is advanced. Reverse, if rows are different, then A's row, A's value, A value. Okay, I think this should be clear. Look at the other possibility. If B has got a lesser row, then B's row, B's column, B's value. So this takes care of both. Now it is possible that one of them finishes because they are linked list, one finishes because one may have fewer values than copying from the other. So if A finishes, I have to copy the value from B, or reversely B finishes, I have to copy the value from A. Alright, I think this part we have seen. Okay, that is about adding. I would want you to go further and look at the program. This is an algorithm. You can just transfer it straight into a function and program. Now printing. Okay. While printing to what is given to me for a particular matrix, input A, B, and the addition C has to be printed on paper on display as a matrix. So you cannot put them as linked list. So in order to print, when do I print? I print when a particular I equal to a row and its J in my loop equal to a column. So I use again the same matrix print format of two loops. Let's say n and m or n and n, whichever. In this case we have taken a square matrix case. Use your next line character to get the next row. Then if for a corresponding row there is an entry in my P and a corresponding entry J, there is a column, which means I have a value. Then I will print the P's value, the value there, and advance. Else the value is 0. So I print 0. So either I print the value or 0 and proceed. So this will give me my resultant matrix. I think it should be clear. Please go through, transfer into a program, understand, take to matrix, work out first on paper, and it should be clear. Thank you.